King of Cups. Diplomatic, balanced, fatherly. This card inspires warm and civil diplomacy with an even-tempered patriarchal hand. Follow your intuition to expertly outmaneuver obstacles and bolster those around you through steady encouragement. This card signifies a stable intersection of emotions and impulses. Like its cousin, the Boldfly Agaric, the Verdigris Agaric reigns over the forest floor but with a more subdued aura. Its color and vibe are cooler, but no less commendable. Bum, bum, bum. Welcome to our episode over the Verdigris Agaric. My name is Ash. Welcome to the Fungi Oracles, where we talk all things fungi, and we're led through a tarot deck called Midnight Magic by Sarah Richard. What I just read in our intro comes from the little book that comes with the tarot deck that tells you all you need to know about tarot cards and just gives us a little bit of insight into where we're going for today's episode with our lovely Verdigris Agaric. If you've been listening, you know that at the end of each episode, I draw a card from this tarot deck and it tells us where we're going to go for the following episode. So at the end of episode 2, a couple of weeks ago, I drew the King of Cups. And the King of Cups in this tarot deck represents the Verdigris Agaric, also known as Stropharia aeruginosa. And that's what we're going to be focusing on today. It's very cool. I'm very excited to tell you about it, per usual. I am not going to pick favorites, but maybe each episode will just be my favorite as I'm talking about it, because right now the Verdigris Agaric is indeed my favorite. It's very blue. Anyway, I'm not going to give you too many hints yet because we have some business to cover. For one, thank you for being here. I'm so excited that you're here. I'm so excited that you're back if you've been listening. Have you followed our social media accounts yet? I sure hope so. You were supposed to do that homework assignment before you came back today. If you didn't, it's okay. I'm very excited that you're back anyway. But our social media accounts, we have one on Instagram and TikTok. It's where I've been posting all the updates throughout the Fungi Oracles infancy. You can find those social medias at the Fungi Oracles, all lowercase. If you go there, you'll find lots of different resources like transcripts for our episodes, sources for our episodes, and a lovely link to our Fungi Friday drop, which is just a Google form that you can drop pictures of any fungi that you took pictures of throughout your week. So please go to those social media accounts at the Fungi Oracles, all lowercase. We're already getting a little bit more of a following after these first couple of episodes, which I'm very excited about. And if you follow on there, you'll see all of the updates. I'll keep you updated. I'm posting fun things like trivia and polls and pictures, etc., etc. Good things are happening, at the very least, on Instagram. TikTok, we'll get there one day. I am making videos, so at the very least, you can see my face. As we get into our episode today, I'm very excited as we lean more into the Fungi Oracles and we're continuing to get used to this process. I'm going to continue to change things here and there, not too much because we're still going to talk all things fungi and we're still going to focus on just one fungi species today. But don't be overwhelmed if I start to change the structure of it a little bit. Just know that I am going to talk about everything still. And as I'm doing that, I might even give you more information that has been left out of the past couple episodes. I told you at the beginning that we were going to start off pretty slow, and as we're learning those, what I'm calling Bio 101 words, we will get a little bit more intense each episode, and that's going to happen again today. I will remind you of past terms that we've learned because a lot of the terms are pretty similar because each episode we are still just dealing with fungi. I shouldn't say just. We are dealing with fungi and it's so exciting. But I'll continue to remind you of that vocabulary that we've been learning so that we can build off of that a little bit and get more detailed as we're getting into these episodes. And that's going to be a part of what we do today as we're learning about this Verdigris Agaric. The Verdigris Agaric, like I said, it's very blue. I'm going to say that a million times because I need to get the point across that it's so blue. And it has a lot more going on, and I can't wait to tell you all about it. We first are going to take a little bit of a break as we do. So get up, stretch, get ready to learn today. Maybe get a few extra steps in, find a comfy spot across your house, and I will talk to you in a few minutes. Tomorrow is the last day of Pride Month, and if you're like me, you may want to end this month with a small act of kindness. One of my favorite organizations to donate to is the Trevor Project, an organization that focuses on supporting and advocating for queer youth. They provide counseling, peer support, public education, and so much more to young people who are in need of support and guidance. I will be ending my Pride Month by giving a small donation to the Trevor Project, and I wanted to encourage you to as well. Remember, no amount is too small, and spreading the word is also a great way to help. This is in no way a sponsorship, but a small way to encourage others to end one of my favorite months with a small gesture that could go a long way. Our Verdigris Agaric, also known as Stropharia aeruginosa. Today we're going to start by talking just a smidge about its niche, how it's fitting into its ecosystem. Then we'll talk about the anatomical structure, how we would identify it, and then we will talk about its life cycle as well before we get into our first break. Stropharia aeruginosa. The genus is going to be Stropharia, and these fungus that fit into this genus are saprobes or saprophytes. We learned what this word meant a couple weeks ago with our piggyback rose skills. A saprophyte is a type of decomposer, specifically a decomposer that is going to release digestive enzymes externally and dissolve nutrients from dead organic material. The dead organic material that the Verdigris Agaric enjoys are going to be things like wood chips, leaf litter, and other dead plants in the area. And so typically we're going to find them where there will be lots of this organic material, like forest, coniferous forest, deciduous forest, where there's going to be lots of this leaf litter to go around. Even with lots of leaf litter to go around, the mycelium network of these Verdigris agarics are going to be quite localized. And here's where we start with the anatomy. Remember, the mycelium network for our saprophytes are going to be underground, typically, or in the dead material that they're decomposing. So we're not able to really see the mycelium network unless we dig and try to. But again, they're pretty localized. So this is not going to be a mycelium network that is going to be spanning for miles and miles and miles. The Verdigris agarics are going to have mycelium networks that are more just centimeters to maybe a few meters. This is also the first species that we've discussed that does not have a vulva. So what we can see, we're not going to start with that vulva today. Instead, we're going to just start with the stem because that's what they pop up as. A mature Verdigris agaric is going to have a stem that is about 4 to 8 centimeters in height and 5 to 10 millimeters in diameter. So it's a pretty thin stem. And at the max, we're getting to about 8 centimeters in height. It's going to be white. And about 3/4 of the way up the stem, we have a new structure that we haven't gotten to talk about yet, which is very exciting. This new structure that we're going to talk about today that's on our Verdigris Agarics is going to be an annulus. This is going to be a ring structure, and it's just like an extra membrane ring that goes around the stem. On the Verdigris Agaric, again, we're going to want to look for that about 3/4 of the way up the stem. And that's coming from a different structure that we have yet to talk about called a partial veil. So if we have a little stem popping up and a baby fruiting body is starting to form, on the Verdigris agaric, covering the gills, we're going to have a partial veil. That partial veil is there to help protect the gills while the mushroom is developing, but it doesn't stay there forever because eventually the veil will need to go away so that the spores can be released. When the veil does indeed drop, it creates that annulus or that ring around the stem, just these extra remnants falling down. And so it's this ring, it's pretty identifiable. And if you're going into these woodlands, that would be one way that you would be able to identify the Verdigris agaric. If we're still talking about the stem, under that annulus, the stem is described to have these white woolly scales, so it looks quite textured, but above the ring or the annulus, it's going to be very smooth and white. So we also have that distinction of below the annulus, it's scaly, above the annulus, it's smooth, and that's going to be another way that we're able to identify it. Some of the descriptions I saw mention that their stems can be a bluish green color, but when I was looking at pictures, nearly every single picture I looked like had a white stem. So I'm going to tell you that they're white, but I guess a possibility of a bluish green color as well. It does change color over time. So as we're heading towards the decayal process, we would have stems that are going towards that yellow decayal color that we've grown accustomed to with our cute little fungi species. Now, if we have the stem and it's now up to its full height and we have that ring 3/4 of the way, we need to talk about the gills and the cap. The gills are going to be described as crowded and broadly attached to the stem. A couple weeks ago, we discussed crowded, meaning that there are a lot of gills, broad, meaning that the gills are going to loop down from the cap and then they will make a 90-degree turn back up to the cap once they've reached the stem. So they have this really broad width of gill surface area to produce spores on. And notice that this time I use the word attached after broadly. Attached means that the gills are going to attach to the stem. At the past couple of mushrooms that we've talked about, the gills have been free, so we had that hollow ring around the stem before we got to the gills. But with our Verdigris agaric, we're not going to have that hollow ring. Instead, the gills are going to just simply attach to the stem. The gills are going to start off this pale gray and white color, and then as they mature, they're going to turn into this brownish, deep purple color. This is because the spores are physically changing colors. So, more in its infancy at the beginning of development, the spores are going to be white, and then as time goes on, they're going to mature into this deep purple color. Sometimes the annulus will catch some of those spores as they disperse, which will also change the color of the annulus, but that really just depends on how the spores are going to be dispersing if the annulus catches any. Then we have my favorite part, our very boopy cap. In this case, our very boopy cap is absolutely stunning. It's turning heads everywhere. The cap is going to be anywhere from 3.5 to 8 centimeters in diameter. It's going to be a bell or a convex shape. On the cap, sometimes we'll have the central area that forms a little bit of a bump, which gives us a perfect boopy area. And it's going to be a very, very pretty deep blue, green, turquoise color. Absolutely beautiful. If you haven't seen pictures yet, I highly suggest pausing and either going to Google or even better, going to at the Fungi Oracles, all lowercase on Instagram, to look at the pictures that I've posted of the Verdigris Agaric because seeing it really brings to life what's going on here. Another very identifiable structure that's going to be on top of the cap is going to be this thick, gluttonous slime. Gluttonous, sticky, mucilaginous. It's made of these complex sugars, also known as polysaccharides, also some starches as well. The word gluttonous sounds a lot like gluten because it has a similar texture to gluten with it being slimy and sticky. It makes the Verdigris Agaric super shiny, almost glossy, so it looks ooey gooey but beautiful at the same time. In addition to the slime, the caps sometimes have remnants of that partial veil that we talked about hanging from the cap. So if the partial veil falls and some of it stays on the cap instead of forming that annulus completely, the remnants are going to create this really striking contrast between the turquoise cap and the white veil remnants that are hanging off the sides of the cap. It's giving kind of princess, not quite, but kind of. The veil remnants do decay pretty quickly, and the slime also dries out pretty quickly as it's heading towards maturity and decay. But if you can get it in that perfect time period, maybe 12 to 24 hours or so, it's just striking. Also, some of those white veil remnants can fly up to rest on top of the cap. So then we have these white spots that are, again, forming just this beautiful contrast between the turquoise and the white. And those pictures are very beautiful. So I highly suggest going to look at some. As it's heading towards decay, it's going to start losing the really pretty color of the turquoise. Instead, it's going to change to more of a yellowish decay color, like most mushrooms do. And I want to talk about the timeline a little bit with the Verdigris agarics and how it's going from this very pretty, slimy, gooey, lovely, boopable little guy into decayal and how this process starts all over again. Like most apotrophic mushrooms, peak fruiting season is going to be from July to October. This is because when we have a lot of leaf litter, there is going to be more of the dead organic material for the mycelium to decompose, and they're going to have all of this energy to form those fruiting bodies. Let's pretend we're a little spore. We've just found some really nutrient rich soil, and we're so excited to start dividing, and building our mycelium network. The mycelium network of the Verdigris agaric is only going to grow about 3 to 5 millimeters per day, which is moderately slow for a fungal species. But remember that the mycelium networks of the Verdigris agarics are pretty small anyways. They're really limited to specific areas that have loads of this dying or decaying organic material. So growing slow isn't a huge deal for them. Once the conditions are just right, it's typically going to be in those late summer or fall months for those of us in the northern hemisphere. So we're looking at temperatures of around 70 to 81 degrees Fahrenheit, which equates to 21 to 20 degrees or 21 to 27 degrees Celsius, excuse me. And we also need really high humidity. So 85 to 95% humidity is what we're looking for. The mycelium, as it's getting these perfect conditions and as it's sensing these perfect conditions, and it has all of this energy because it's decaying all of that leaf litter, it's going to form the babiest of baby pins. It's going to take about 5 to 10 days once the mycelium network is ready and senses conditions are right before those babiest of baby pins are going to pop up. But after about 5 to 10 days, we can see those baby pins pop up from the ground. If you're like, what is this person talking about with the babies and baby pens? For one, you should maybe, if you want to, go and listen to our first 2 episodes. But the pens are just baby mushrooms, and it's going to be a fruiting body in its infancy. Once we see those pens, about 5 to 10 days after the mycelium network is ready, the pens are going to have that partial veil on it. The partial veil is going to be covering up the gills, so we can't see the gills quite yet. However, when they first pop up and they have that partial veil, the fruiting body, the cap of it, is going to be at its most vividly turquoise. This is also when we're going to be at our slimiest of all slimies. So it's very, very ooey gooey at this point. Over the next 3 to 4 days, those babiest of baby pens are going to grow and they're going to fully develop by pretty much day 4. It happens pretty quickly. By day 3 or 4, we have a full grown mushroom, and therefore we see that partial veil start to fall and become the annulus, and we see the remnants of that partial veil sticking to the cap as well. We know that the fruiting body is mature once the cap starts to flatten and slightly change colors. It's going to go from that turquoise color to the yellowish tan pretty quickly. As soon as the partial veil drops from the gills, those spores that were cooking up inside of the gills are absolutely ready to go. They are going to start dispersing through wind dispersal, and after those spores leave the mushroom, then the mushroom is going to start to decay. The slime dries out, the cap flattens even more, sometimes even becomes concave, and we see all of those partial veil remnants completely wash away or dry out. It's happening very quickly. After about 3 days after spore releasal, or dispersal, I should say, the mushroom is going to be completely decayed. The decay process is going to be all done. The new spores are going to go and find, hopefully, some nutrient-rich soil with lots of leaf litter so that they can form a mycelium network of their own. And we're done, right? You know me better than that by now. We must talk about reproduction. Spore production in Verdigris Agaric is going to happen mainly through sexual reproduction. So we have to have one mycelium network find a compatible different mycelium network. They have to be genetically diverse, and they are going to combine their genetic information eventually to form some new spores. This is done through those basidium cells that we learned about a couple weeks ago. It's a really common way for mushrooms to sexually reproduce. Remember, the mycelium networks are going to meet underneath the ground. They're going to hug, they're going to love. When that happens, the cells from one mycelium network are going to intertwine with the cells from a different mycelium network, forming some dikaryotic myceliums. In those cells, we have all of the cellular information mixing up except for the 2 nuclei, where all of the genetic information is at. So while it's in the mycelium network, those 2 nuclei in the cell are going to stay separate. However, when we form that fruiting body, or the mushroom, what is happening is we have those basidium cells, and in the basidium cells, the nuclei are going to combine. They're going to combine. Once they combine, the genetic information that's inside of them can cross over. Once that genetic information crosses over, then the cell can divide into our 4 different haploid cells. And now that we have our 4 haploid spores, those spores can go about their way and find that nutrient-rich soil and create their own mycelium network to find another little haploid mycelium mate so that they can start this process over again. We'll review this every time that it comes up. I'll go a little bit quicker each time, but nice, easy sexual reproduction. Verdigris agarics can undergo asexual reproduction, but it's in a bit of a different way. How it's going to work is through mycelium fragmentation, which is when a part of the original mycelium is going to break off, and we can transport that mycelium to a different area, and the mycelium could continue to grow. And if that mycelium continues to grow and it's already dikaryotic, then it could theoretically create its own mushrooms, its own fruiting bodies. If it's not dikaryotic yet, then hopefully it will find another mycelium network that is compatible so that they can reproduce on their own as well. Kind of like propagation, if you're a houseplant person, I'm sure that at some point in your houseplant career, you've had a succulent, and if you take those succulent leaves off and put them in their own little pot of soil, then that little leaf could form its own succulent, and that would be a type of asexual reproduction because it's just fragmented or propagated. We're thinking the same thing here with our Verdigris agaric's asexual reproduction. So technically, it could undergo either, but it's spending all of its energy on creating those basidiospores with the sexual reproduction because it's confident that the spores that it's creating, which by the way is anywhere from 1 to 3 billion spores, are going to be able to disperse through the wind, find the lovely conditions that they need, and form more mycelium networks to sexually reproduce with different mycelium networks. And then finally, the process can start over again. Now that we've reached the end of the life cycle, or we've brought us back to the beginning, I should say, I would like to take a quick break before we go on to our evolution, taxonomy, adaptation section. So please go blow your nose if you need to, eat some tortilla chips, and I will see you in a couple of seconds. Do you like books? Books of all kind, whether they be romance or fantasy or the latest historical fiction? If so, I have the perfect place for you. On Instagram, if you go to Lit Latte and Lawyer Live, you will find my dear friend Olivia and all of her wonderful and lovely book recommendations. The book recommendations come from the highest esteemed authors to indie authors and everything in between. Go to Lit Latte and Lawyer Live on Instagram for your next book recommendation and cute little book find. Welcome back, welcome back. I have some big news. The big news is that we're going to officially rename this part of our episodes as the taxonomy and adaptation section of our episodes. In the couple of episodes before, I've been calling it evolution, which is still a little bit true. We're going to talk a little bit about how they evolved, but the research is really lending more towards taxonomy and how these species fit into their kingdom, phylum, class, order, family, genus, and species. And if you're a little bit overwhelmed by what I just said, taxonomy is simply us categorizing and classifying every single species on the planet in 7 different ways. When we start at kingdom, those categorizations are going to be really, really large. And then as we work our way down to the species, it's the most specific that we'll get. Depending on the episode, I might start all the way up at phylum because remember, all of this is kingdom fungi. So I might start at phylum sometimes. I might start way down at family sometimes. It's really just going to depend on the species that we're talking about. And today, we're going to take it a bit slow and we're going to just start with the family that Verdigris Agaric is going to be fitting into. And then we'll talk about its genus. And then we'll talk about why its species is so different than other species. We are also going to talk about its adaptations. How does it thrive in its environment as its own species? after we talk about those two things, we'll talk about where we can find these verdigris agarics today, and then we'll end our episode with some human interactions that we have with these verdigris agarics. All right, so the verdigris agaric is a part of the family Strophareaceae. This family, Strophareaceae, is thought to have evolved into their own family of mushrooms around 66 to 71 million years ago, which puts us at the very end of the Cretaceous period, right before that cataclysmic asteroid hit Earth. This means that mushrooms within Strophareaceae were probably very, very influenced by the conditions that arose during that time, because that cataclysmic asteroid killed 75 to 80% of the plants and animals that were on the planet at that time. If you're a fungi, that is thrilling for you because you have so many things to decompose. It's a perfect scenario. There's so much decaying material. It literally couldn't have gotten better. Mushrooms, fungi within Strophareaceae are characterized as mushrooms that have brown or deep purple spores, bright colors on their caps, and they're going to be very sticky slash slimy in their infancy. So every fungi within Strophareaceae are going to have those similar characteristics. Then, if we make it a little bit more specific, we have our Verdigris agarics fitting into the genus Stropharia. Stropharia has about 40 to 50 species in it, and it has been going through a lot of reclassifying lately. Lots of scientists are reclassifying mushrooms and classifying them either as Stropharia or taking them out of the genus and moving them somewhere else, just dependent on their characteristics as these mycologists are doing more and more research. But our Verdigris agarics are there for now because of their saprotroph lifestyle, partial veil, blue-green color, and attached gills. All of those characteristics fit specifically into Stropharia. Then, of course, the Verdigris agaric is its own species, and what makes it its very own species and different from the other fungi that are in Stropharia are going to be those partial veil remnants that we see on top. The fact that the edges of their gills remain a stark white color even as spore color changes. The woolly scales on their stem are a big giveaway. And then last but not least, that super slimy cap. It's going to be a bit slimier than any of the rest. Other species within Stropharia might have some of these characteristics, but not all of them put together. And all of those characteristics put together is what makes Verdigris agaric its own little species. How do all these characteristics support Verdigris agaric's survival? I want to start with the partial veil because this is a new structure for us today. That partial veil is going to serve as so much protection. It's going to help protect the gills that are so important, because if the gills are destroyed, then that fruiting body is not going to be able to produce any spores, and then it's literally like, what was it all for, you know? So that partial veil is going to be a great adaptation to help protect the mushroom, especially while it's in its infancy. Those woolly scales on the bottom of their stem help protect them from predators as well, just giving them a little bit more physical protection. Most importantly, what I think is the coolest is that gluttonous slime is going to keep the fruiting body from drying out early in development. And that's why it's so extra ooey gooey slimy at the very beginning when there's still those pins. It's going to be extra slimy because it needs all of that moisture for the fruiting body to stay viable so that it can create those spores within that 3 to 4 day time period. The entire goal is to give the mushroom enough insulation, moisture, protection from predators so that they can create those spores, because once they create the spores go on their way and then they can die. Their job is done. All of these characteristics are going to give them such an advantage to really thrive in their environment. Why don't we talk about their environment a little bit more? Where can we find these guys? Another day, another mushroom that we find in Ireland and the UK. The conditions in Ireland and the UK are just absolutely optimal for fungal growth. So it's very lucky for Ireland and the UK. They get all of these species to just sit and all at. It's relatively common in these areas, and there are tons of pretty sightings reported throughout these areas. It's also well documented in the United States, specifically the Pacific Northwest, as well as Canada, specifically British Columbia. It can be found in the northeastern United States. It's just much less common, but there have been sightings in New York, Pennsylvania, Massachusetts. It could exist in other states as well, because really this is all about those optimal conditions and a nice dense forest, lots of leaf litter, and those optimal temperatures anywhere from about 60 to 80 degrees Fahrenheit. Western Russia and Siberian regions are going to have these verdigris agarics. Iran, temperate areas in China and Japan, and then some have been spotted in Australia and New Zealand as well. But the hypothesis is that they were introduced into those areas, so they aren't quite native there, and therefore they're not going to be colonizing as well. It was first discovered and described in 1784 by British naturalist William Curtis. He originally named it the Agaric aeruginosus. Throughout the next century, as further observations were made on the Verdigris agaric, French mycologist Lucien Culet renamed it Stropharia aeruginosa, moving it to the genus Stropharia. So this like reclassification happening for Stropharia has been ongoing for a little while. He reclassified it as Stropharia aeruginosa because in Stropharia we have those annulus or the rings, and Stropharia actually is going to translate directly to a belt, which is going to reference that annulus around the stem of our Verdigris agaric. And then aeruginosa directly translates to verdigris, actually. And that word verdigris is going to mean green or blue. So Stropharia aeruginosa is hinting at a couple of the characteristics that we're seeing. At the time that he did reclassify it, the Verdigris agarics were still grouped in the same species as the blue roundhead, which is its evolutionary cousin. It wasn't until 1979 that German mycologist Hans Kriesel published a paper forming clear distinctions between these two species. Some of those distinctions being a speckled cap versus a smooth cap, general stem structure, and then the color of those gill edges as well. So it wasn't until 1979 finally that the Verdigris agaric has its own little branch on the taxonomic tree of fungi. We see it described slightly in U.S. recordings by Charles Horton Peck as he was describing Stropharia species in the Pacific Northwest, but I couldn't find anything specific on first sightings, and my assumption is just because they're so much more concentrated in the UK and Ireland. So it makes sense that we're seeing and recording more of these sightings in the UK versus the United States. But that takes us through this nice little history glance into when it was first described, when it was first discovered, and how it got its name, which I think is so fascinating. Last but not least, we should talk about how humans interact with the Verdigris agarics. For humans, the toxicity of Verdigris agaric is debated. Most Northern American guidebooks deem them as toxic. Some European resources deem it as edible and having a slightly spicy taste. We don't know much about the toxins or lack thereof in Verdigris agarics, at least I couldn't find much, but they have been documented to cause gastrointestinal symptoms like nausea, vomiting, diarrhea. So I wouldn't listen to those European resources. As always, do not take any advice. Do not take the advice from the European resource books saying that they could be edible. I'm not here to give you that advice because I am no way, shape, or form a mycologist or an expert. I don't know why you would want to eat an ooey gooey mushroom, but maybe if you're really desperate, you might want to eat an ooey gooey mushroom. You might want to see if it tastes like blue raspberry or something. The main perks that we get from Verdigris Agaric are simply looking at them, admiring them, snapping pictures of them, and of course, they're decomposers. They help us all the time. They do have other symbiotic relationships in their environment with organisms that aren't humans, like slugs, snails, other small insects trying to have a tasty meal. Specifically, fungus gnats and beetles use them as breeding grounds, and a lot of those little insects can get some moisture off of the slime. We might see smaller rodent species eating them as a snack as well, but it's not entirely common because again, it looks like a little bit of a freaky meal. Like we're not going to go out of our way to eat the mushroom that is a turquoise color. If you're a little squirrel, then acorns probably seem like a much safer choice. All in all, humans can admire the relationships that these Verdigris agarics have with other species. We can ask questions about the adaptations of the Verdigris agaric, and asking questions about any fungal species keeps not only mycology moving, but loads of other science disciplines as well, like ecology, like toxicology, and even medicine. We have created so many different medicines with the help of fungi. I'm confident as we continue to find out more about the Verdigris agaric's toxicology, it can just continue to open up doors that wouldn't be possible without the Verdigris agaric and other mushrooms like it. Mic drop. That brings us to the end of the information that I have for you about the Verdigris agaric. So to recap, it's a very pretty mushroom. It's pretty identifiable with the analysts and with the turquoise and with the ooey gooeys. And it's still a little bit debated where it fits in. At least it was up until the 70s. And if it was up until the 70s, I'm sure we could still debate that now. We find it in lots of places around the world, and the main perks that we get from them are admiring them. How lovely for the Verdigris agaric. That, my friends, brings us to the end of our third episode. And with the end, you know what that means. You know what time it is. It is Midnight Magic time. Midnight Magic by Sarah Richard. I am going to go ahead and pull her out. We will do a quick tarot pull to see where we're going in a couple of weeks. Let's do it. Okay. All right. We have, oh my goodness, the Anemone Stinkhorn. Oh my gosh, this is so fun. I am not, hold on. Azero rubra is the scientific name. So we're going to be doing the Anemone Stinkhorn, also known as the Arazro rubra, which I am surely mispronouncing, and you're going to have to wait until 2 weeks from now to get the appropriate pronunciation for that. This is the Ten of Swords, so I cannot wait to tell you what the Ten of Swords is all about, and more specifically, our very fun looking and a little scary looking Anemone Stinkhorn. Thank you so much for listening today. Again, I'm so thankful that you want to learn about fungi. Truly, from the bottom of my heart, I am so thankful that you want to learn about fungi. They've always brought me so much joy, and this is just a way for me to share that joy with the world. Please, as your homework assignments, per usual, go to our social media accounts at the Fungi Oracles, all lowercase. please take pictures of any little mushroom guys that you see throughout the week on your walks. Please go on walks, they're good for you. And post those pictures to the Google form that I have in our link tree so that I can share them with the world. The world being our lovely, small, little social media accounts. But those lovely, small social media accounts will grow, and then everyone can see the lovely mushrooms that are living in your areas. And we, again, can all have some good and fun, loving fungi together. That, my friends, brings us to the end. Thank y'all. I love y'all. And I'll see you in a couple weeks for our Anemone Stinkhorn. Bye bye.